Okay, for the pre-reading questions, Elvis, our shy guy, would go over here, and then it shows that, like, Marta would probably go closest to the driver, and they don't like to sit to each other. Okay, and then we talk about how many protons are in a lithium atom. It's right there, number 3. And then because it's an atom and it's neutral, there are 3 electrons. And what do we see when we put a 1s and the 2s? You should see 2 electrons spinning exactly opposite one another, close to the nucleus. And one by itself further away. And it is correct. The alpha principle states that electrons occupy the highest energy orbital. Click on the 1s box. What is the electron configuration of hydrogen? It's 1s1. The orbitals, what do you notice about the arrows? They are opposite. One up and one down. Pauli exclusion principle. Electrons sharing an orbital have opposite spins. Electron configuration of helium is 1s2. This would be 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1. Feedback that's given if we try to put it back in the first orbital is that it is a bad arrangement or something to that effect. Is the configuration correct now? It is, and it would be up, down, up, down, up, up. So just like the bus, these guys want to be by themselves. And how are the electrons in the 2p subshell similar to passengers on a bus? They sit by themselves until they have to partner up with somebody else. Wow, my handwriting is really terrible. Nitrogen is 1s2, 2s2, 2p3, 1s2, 2s2, 2p4, 1s2, 2s2, 2p5, up, down, up, up. And then I'm not going to fill these in. You guys know how to fill those in. Up, and then a down. Up, down. And then neon has a full second sub-level. So 2s2, 2p6. So we'd fill in every single one of these with electrons. What can you infer about the radioactivity of helium and neon? They don't react. Because they have a full shell. S and P, those 2 tower electrons are just there. How does this row reflect the subshells? A letter S, P, others, which you already know are D and F. Okay, first question is a prediction. You may remember from the magnet lab that we did, so what's going to happen here. Sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. And what you should notice, and you guys can fill in the rest of these, what you should notice is that as we go across these numbers become smaller. So how does the atomic radius change? It gets smaller. Those atoms are more closely attracted to the nucleus. Let's skip ahead. How do you think the size of the atoms change from top to bottom? That's your question. Hydrogen, lithium, sodium. What you should notice about these, I don't know the exact numbers, but they all go up. How does the atomic radius change? It gets bigger, and the reason is because we've given them more space. So just like the magnets, we've given them more space to move around. Why does the atomic radius decrease as electrons? They are more closely attracted to the nucleus. How does the atomic radius increase as you go from the top to bottom? Because we've given them more space we've made the atom bigger. Compare the electron configuration of hydrogen, lithium, and sodium. Why do you think these atoms are grouped in the same family? They all have one electron in their s and p orbitals. What feedback is given here? You should get an error message of some kind. The 4s subshell is lower energy than 3D. Okay. And you should click. Is the configuration correct? And the configuration for potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Calcium would be the same. 1s2, 2s2, 2p6, 3s2, 3p6, 4s. One more electron is 2. Scandium. Scandium would be the same as what's up here, except the next thing would be 3d1. Scandium's first element to contain electrons in the d subshell. How many orbitals does a d subshell have, and how many electrons can fit? There are 5 orbitals. And that means that you can fit 10 electrons. Middle selection, what do you think this section is? 10 columns wide, 5 orbitals, 10 electrons. And then this is called the diagonal rule, but this is what we talked about, and that's why we had a little bit of time to make the periodic table, because I kind of want you to see that without doing all of this. But you can kind of see what subshell is filled after P, and it is 5s. 6s, what comes after 6s? Well, we look here, and then we see 4f. And after 5d would be 6p. But I don't want you to have to memorize this. You already have a table, and it's already arranged in this order. What a mess I made. Electron configuration for these. Hopefully we're in good shape on this stuff. Cobalt, I'm just going to give you the last ones. It would be 3d8. It would end that way. Germanium would end with, I'm just going to do the, let's do the abbreviated, 4s2, 3d8. This one would be 4s2, 3d10, 4p2. Yttrium would be 5s2, 3d1, 4d1, sorry. And neodymium is ND. Some of you may know neodymium. It's really strong magnets. Neodymium would be 6s2, 4f3. Gold, AU, would be 6s2, 4f14, 5d9. How many elements are in the lanthanide series? There are 14. Subshell is an F subshell. This is, I'm sorry, 4F and 5F. In general, how is the shape of the periodic table related to electron configurations? We talked about this. They are in blocks that we cut apart, and we should know where they are.